Hey everybody, it's Mr. N here, and this is the next section, which is on reflections. So let's go ahead and get started. And let's take a look here at what we have about a reflection. A reflection is a transformation that moves a figure, the pre-image, by flipping it across a line. So what we're going to do is we're going to flip across a line of some sort, and that will be our reflection. The reflected figure is called the image. A reflection is an isometry. Why is it isometry? Because it's not changing the size or the shape of it. So it's only moving it somehow. So the image is always congruent to the pre-image. Okay, so it's like a mirror effect. So if I look at a mirror, I'm looking at a reflection. So the same thing goes here. So if I put a point, and we'll just use this one here that I have. If I put point P and I reflect it about this line, that means I'm going to flip it this distance over that line. So that's how we can define this. So a reflection in line M maps every point P to P prime such that if P is not on line M, then M is the perpendicular bisector of PP prime. And if P is on line M, then P prime is P. So here's what it's saying. I put point P, I'm going to reflect it. I'm going to flip it across. I'm going to use a different... So here's point P. I take this same distance, and I'll, as long as it's perpendicular, because it's got to be along this perpendicular bisector, and I will flip it to the other side. Just like if I started here, I would flip it to the other side. Here's Q, I flip it to the other side. Now, if you are on this line of reflection, that's what M is called. So M is the line of reflection. If you are on the actual line of reflection and you flip it, you don't go anywhere. So now let's take a look at the notation. Here's the notation. When we use reflections, we use this R sub M. So that means a reflection about line M. So this is reflection about line M. That's what that stands for, R sub M. So now we can say, with our terminology here, let's go back to the lightsaber, reflection about M such that P maps to P prime. You could do it with compositions. You say a reflection about M where point P will equal P prime. So this means R sub M, reflection about M, maps P to P prime, or P is reflected in the line M to P prime. We said a reflection is an isometry, so that's just reminding you. Now, here's how we can reflect with the coordinates. And here are 4 that I've listed for you. Okay, the first is, what if you have a diagonal line, y equals x? If you have other lines, it's a little bit more difficult, other diagonal lines to break down. So we're going to stick with some basic ones right now. If you have the line y equals x, and here's what I mean by that. Suppose I had my coordinate, and here's a line y equals x, like this. And if I put a point P over here, you know we're going to go perpendicular and reflect it. Whatever this distance is right here, I'll make that distance on the other side the same thing. That would be P prime. That's how we reflect it. So if we're given coordinates, here's what happens. x1, y1 becomes y1, x1. So this is P right here, and this is P prime. So look at what you did. All you did was flip the x and y. So look, if I went a distance of x and a height of y, now I'm going a distance of y and a height of x. So it flips the x and y. If you're doing a diagonal line the other way, this way, so y equals negative x, then x1, y1 becomes negative y1. Look at, you flip and you put negatives. So switch the x1 and take the opposites. Then if you reflect about the y-axis, okay, the y-axis is this one. So if here's our x, there's our y. So if I'm reflecting a point, say point P over here, about the y-axis, I would take this distance right there, do the opposite way, P prime would end up here. So look what's happening. your x becomes the opposite, but your y stays the same. So right here, your x becomes the opposite, but the y stays the same. So here's p, there's p prime. And just like if you were to do it about the x-axis, so this going down here, so let's do that one also. So if I had, let me get another color here. So I would take this distance, take that distance if I'm reflecting about the x, this would become p prime. Notice this time the x's stay the same, but the y's will change. So x, y takes the opposite. So this is something that we developed right here. I showed you in the graph, but if you forget it, it's probably best that you just memorize these. And here they are again, right down here in a little graphical representation. Over here, reflect about the x. There's p prime. Notice you go x, stays the same, y you take the opposite. So xy becomes x, negative y. Over here, p and p prime, you're going across the y-axis. So the x becomes opposite, but the y stays the same. So xy goes to negative x, y. And then over here about the line y equals x, we're going to go ahead and flip the x and y. And this graph doesn't show y equals negative x, but we need to know that one as well. And then we said it's an isometry, which means it is a rigid motion. And now that we know what a reflection is, we could talk about this one that I had mentioned the other day, what a glide reflection. So glide reflection means two things. We're going to glide something, and then we're going to reflect it. And you do it in the order that we say it, glide reflection. So a translation and a reflection. So first we're going to glide, slide, translate, whatever you want to associate that with, because that's what it means, from A to A prime, B to B prime, etc. And then we're going to take all these A primes, B primes, C primes, and then we're going to flip them. So then we reflect them, so A prime becomes A double prime, B prime becomes B double prime, and so on. And we will do examples of those as well. And then the next thing is we need to be able to reflect around a line, so we know that we can end up with certain shapes that have a line of symmetry. A line of symmetry is when a figure can be mapped onto itself. So take a look. Here are some examples. How many lines of symmetry does each hexagon have? Now, when I say mapped onto itself, think of it like folding a piece of paper, and then you're going to get the two parts, or the left half and the right half of whatever figure you're going to match right on top of each other. That would give me a line of symmetry. So over here, for part A, if I cut this right down the middle and fold it, notice all these parts will fold onto the other ones perfectly. So it has a line of symmetry down the middle. It also has a line of symmetry going horizontal, because if I take this horizontal line, I fold the top part and it matches up on the bottom. Over here, check this one out. You've got a line of symmetry here. You've got line of symmetry diagonals. Look at all these different lines of symmetry. Here's a solution for it. So basically, not only do you have one going right down the middle, but you have it diagonally like this. You have it this way. You have it this way. You have it this way. And one more that way, like that. Those are all the different lines of symmetry. For part C, the only one you have is going right through the middle like that. So that just has one line of symmetry, and you can count for the other ones. All right, let's take a look. That was pretty much it. What I do want to practice, though, these are the graphs. I'm not going to do these because the graphs are, well, actually, we could do a couple. Let's take a look. And then we'll do the student journal ones in class. But we can do a couple. Over here, if I'm reflecting about the line M, notice this distance 1 right here. I'm going to put this point becomes that point. So if I call this A, that'll be A prime. Over here, notice I'm going a distance of 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. If this point was B, here would be B prime. And then over here, you could use this one, 1, 2, 3, 4. 1, 2, 3, 4. If this is C, this would be C prime. And when I reflect this, this is what I would end up getting, something like that. So take the points you know and count those distances they are away from it. If it's diagonal, then you're going to have to like guesstimate here, unless it's y equals x or y equals negative x. You would have to guesstimate these perpendicular distances and put those on the other side and draw it. I'm not going to do that because my grid is not big enough there for me to do it accurately. Over here, this distance would go down to here. These distances of 2 would go up to here, right there, and then you would get this reflected triangle. Okay, so over here, these bottom ones, it's what the rules that we talked about. If I'm going to do the x-axis, remember, and I'll draw it out for you again to remind you, if I do the x-axis, this is the x-axis, so if I have a point P here, right, I'm going to flip it this way. So the x stays the same, but the y changes. So on the x-axis, x stays the same. Think of the axis of reflection. That's going to stay the same. So the x will stay the same. The y, if you're going about the y stays the same. It's the other one that changes. So over here, point P and Q, okay, so we would end up with P prime. We said the x was going to stay the same, but the y is going to change. Q prime, the x is going to stay the same, right, -1, but the y will change to be -2. We take the opposite of it. And then when we said for number 6, the y-axis, again, it would be, here's the y-axis, right? Let's just do it in blue. Here's the y-axis. So if I have the point 6,4, or if I have point P over here, we're flipping it this way. So the y height stays the same. It's just the x that changes. So P prime, we said the x is going to be the opposite, so -6, and the y stays the same. And Q prime, we said the x is going to take the opposite, but the y stays the same. And the line y equals x, so remember we just did this one, and we said over here in our notes that x comma y, would map to, and then we flip these, okay? So when we go, if point P is right here, say, oop, that's not a good one. I shouldn't have put it on the line. If point P is right here, right, and we're flipping across this line, now we're just going to do the opposite. So it'll be this and that. The heights will change. Okay, so over here, P prime is going to end up, we flip these two, so 4, 6. And then Q prime, we said we're going to flip these two, just like this mapping tells us to do, and that would be to -1. All right, hopefully this wasn't too bad. We're going to do more of these examples in class for the student journal. Thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.